Rapid intensification, a term used in the field of meteorology to refer to a period of extreme strengthening within a tropical cyclone. According to the National Hurricane Center, rapid intensification occurs when a tropical cyclone increases its sustained wind speed by 35 miles per hour or more in less than 24 hours. This is a topic I have been personally interested in for a long time, but it's something that not many people outside the weather community really seem to grasp. By that I mean the basic mechanics as to why rapid intensification can occur and why the warming of the Earth contributes to more explosive hurricanes. So today I'm here to discuss the increasing rate of rapidly intensifying hurricanes. We will go over what inspired me to make this video today, some recent history of rapid intensification, and how the climate at large affects the development of hurricanes. So let's just get right into it. If you were privy to the happenings in the weather world, I'm sure you saw this coming. But even if you're not, the story has been making headlines everywhere the past few weeks. On October 25th, 2023, Hurricane Otis made landfall near the Mexican city of Acapulco, and it does not look good down there. They are absolutely devastated. Acapulco is a city with just over 1 million people to its name, and what happened in relation to Hurricane Otis is truly terrifying. At 11 a.m. on October 22nd of this year, the National Hurricane Center designated an organized low-pressure system as Tropical Depression 18E. This is the system that would soon become Hurricane Otis. By the second advisory, the storm was given its name. Tropical storm watches were issued for southwestern Mexico, and starting at 5 a.m. on the morning of October 23rd. 12 hours later, tropical storm warnings went into effect, with Otis sitting at a hearty 50 miles per hour sustained winds. Note that a hurricane watch was issued for the same areas as the tropical storm warning as well. At 5 a.m. on Tuesday morning, October 24th, was the first time that Otis was forecast to reach hurricane strength by landfall. So a hurricane warning was issued for the northern portion of the tropical storm warning. At this point, Otis was sitting at a respectable wind speed of 65 miles per hour sustained. And by now, nothing exceptional seemed to be going on with the storm. It wasn't even forecast to make landfall at major hurricane strength. While this surely was going to be a dangerous situation for the people of Mexico, nobody saw what happened next coming. By 2 p.m., Otis had reached hurricane strength, with sustained winds of 80 miles per hour. It was strengthening before landfall, but it didn't have much longer out on the ocean. Landfall was expected sometime Wednesday morning. What happened here, I really don't have words for. And what is possibly one of the most staggering things you could ever see on one of these charts from the National Hurricane Center, Otis explodes into a major Category 3 hurricane with sustained winds of 125 miles per hour. This was after one advisory issued just 3 hours after the prior one that denoted Otis a hurricane. 3 hours later, another explosion in strength to 145 miles per hour sustained winds, making it an extremely powerful Category 4 hurricane. Just 6 hours ago, the storm was a Category 1 hurricane sitting at 80 miles per hour sustained. By 11 p.m., Otis would reach 160 miles per hour, making it a monstrous Category 5 storm. Otis would make landfall shortly after at around 1:25 Central Daylight Time, reaching maximum sustained winds of 165 miles per hour. I know I threw a lot of number jargon at you there, and I apologize for that, but that's going to be a lot of this video. But if we take a second to step back and rally up those totals, Hurricane Otis had a 90 mile per hour jump in sustained winds in just 12 hours. You heard that right, 12 hours, not even 24. From 70 mile per hour tropical storm to a Category 5 hurricane. Need I remind you, rapid intensification allows for a 24-hour time frame to qualify, and Otis smashed it 2.5 times over in half the time. From a meteorological standpoint, this is a wonder. But from the humanitarian standpoint, I cannot even begin to fathom the amount of suffering that this storm has already caused. And that brings me into why I wanted to make this video. A hurricane like Otis shows why rapid intensification can be so dangerous and why it should be more of a concern to us. It may sound obvious, but you need to understand the logistics of what happens when hurricanes approach land from a human standpoint. As a tropical system approaches your area, you have two main options. You can evacuate or you can shelter in place. Obviously, a lot of different factors will play into this decision. How strong is the storm expected to be? How far away is it from landfall? Do you have enough time to safely evacuate? Do you have the means to evacuate, such as transportation, sufficient money? Do you have a place to go? These are just a few of the questions that will play a hand in your decision. Typically, the lead time on tropical systems is fairly lenient though. These storms often form at least a few hundred miles from land, and often take days or weeks to fully develop. Usually, the National Hurricane Center has a general idea on if a tropical system will impact the landmass within the next 5 to 7 days. Within 2 to 4 days, the general area it will make landfall on in a given state or territory is usually pretty set in stone. It may vary a few dozen miles, but typically they have the right idea. Look at Idalia, for example. Even though it came from all the way down south in the southern Caribbean, they were pretty confident that Idalia was going to hit the Panhandle and Big Bend region of Florida for a good majority of the storm's existence. This advanced lead time that tropical systems often get allows people to effectively evacuate if need be, and for those who decide to stay, to have time to properly prepare. The situation becomes a lot trickier when a storm forms closer to land, and will be making landfall in just a few days. On one hand, the forecasts are pretty reliable with that short range, but on the other hand, you don't have much time to prepare for the storm. But what's worse than a storm that forms close to the coastline, leaving little time for preparation? A storm that explodes in intensity after its forecasts remain relatively weak for most of its lead time. Remember, Otis was a medium-range tropical storm for the first half of its life. Otis was forecast to become a hurricane for the first time at 5 a.m. on the 24th of October. By 2:25 a.m. the next morning, a Category 5 behemoth was already ready to bear down. How do you even prepare for that? The keys to rapid intensification are not much different from what we already know drives tropical cyclones to grow. Much like people, a favorable environment is needed for tropical cyclones to truly flourish, and in the case of hurricanes, this involves a few ingredients, these being warm ocean surface temperatures, low vertical wind shear, and of course, plenty of moisture. Vertical wind shear is a term that describes an increase of direction in wind with height. This can be detrimental to the development of thunderstorms, which are often noted within the eye wall of strong hurricanes. In some cases, wind shear can completely tear storms apart. While there can be other factors at play with each individual tropical cyclone, such as seasonal patterns, upper-level wind patterns, El Nino and La Nina seasons, and the specific atmospheric conditions at the time of its development, the previously three listed factors are what you need to know for today's video. These conditions are known to directly correlate to an increase in the frequency of strong tropical cyclones, which brings us to another question. Does the warming of the climate, and by proxy the Earth, affect the rate of hurricanes that rapidly intensify? Well, science seems to think so at least. According to NOAA, tropical cyclone intensities globally are projected to increase on average by 1 to 10%, assuming that the planet warms by 2 degrees Celsius. The Earth has already warmed by around 1 degree Celsius since the Industrial Revolution, and I think it's fair to say we're already seeing the consequences of that, which we will get into momentarily. Now, we can argue all day about whether humans are able to impact the warming of the climate, whether by accelerating it or slowing it. Whether that be, has humanity warmed the climate of the Earth, or would the planet have just warmed up anyway without us here? I'm not here to tell you what to think or to argue that, but the fact is that the planet has indeed warmed regardless of the cause. And with a warmer planet and atmosphere comes warmer ocean surface temperatures. This not only allows for the potential development of more tropical cyclones, but also allows for more of these cyclones to have the ability to become intense hurricanes. So to answer this question, yes, a warmer climate does correlate to an increase in strong tropical activity, and by proxy, rapid intensification. So, what evidence do we have to prove that a warmer climate allows for stronger tropical cyclones to form? Well, of course, I could just spit out a few headlines at you that state that intense hurricanes are becoming more prevalent, but that's boring. And, it's not really believable if you're not going to read the article. So, how about we actually look into some specific examples of tropical cyclones that have rapidly intensified in recent years? We don't have to go very far from home for our first example. I've been meaning to talk about Hurricane Idalia since the video we made covering the storm back in August, and now seems like a better time than ever. I made numerous videos covering the lead up and development of Hurricane Idalia, including its slow start churning away in the southern Gulf of Mexico for days before it fully developed. So for the sake of brevity, our story will start with Idalia already sitting to the southwest of the Florida Keys on the morning of August 29, 2023. At this point, Idalia had just become a Category 1 hurricane with sustained winds of 75 miles per hour. This came after a 12-hour period of stability within the storm, sitting at 70 miles per hour the whole way. By now, Idalia was already forecast to impact the Big Bend of Florida as a major hurricane, so at least a Category 3. 12 hours later, at 5 p.m. Eastern Daylight Time, Idalia had already gained 25 miles per hour in sustained wind, just 10 miles per hour shy of meeting the qualifications of rapid intensification. By 5 a.m. the next morning, Idalia was just hours away from impacting the Big Bend of Florida, packing sustained winds of 130 miles per hour. Idalia had strengthened from a bare minimum hurricane to a Category 4 beast by jumping 55 miles per hour in one day. Idalia's power trip would come to an end though, however, as it began to undergo a eye wall replacement cycle just before landfall, which would slightly destabilize the storm. Hurricane Idalia would make landfall in Keaton Beach, Florida at 7:45 a.m. with wind speeds of 125 miles per hour, making it a very high-end Category 3 hurricane. Regardless of the numbers, Idalia was devastating to the people of the Big Bend region in Florida, and will surely be a storm I remember for a very, very long time. So, while Hurricane Idalia was a pretty good place to start, it is by no means the most extreme example of rapidly intensifying tropical cyclones. Other big names in recent years, such as Ida, Harvey, and Michael, may also ring a bell. But this year, however, has seemed to be a turning point for rapidly intensifying storms, because just a brief time after Hurricane Idalia impacted Florida, we had Hurricane Lee. I personally find this image to be both hilarious and terrifying at the same time. From the first advisory the National Hurricane Center issued on Lee, the storm was destined to be a menace. The 3-day cone indicated it would reach hurricane strength, but models in the 4 and 5-day range indicated that Lee could reach major hurricane status, Category 3 or higher. By 5 a.m. on the morning of September 7, 2023, Lee had obtained hurricane status, sitting at a respectable 80-mile-per-hour sustained winds. But right here is when Lee would start to explode. The very next advisory, it was already a Category 2 hurricane, with wind speeds of 105 miles per hour sustained. Remember when Idalia did that in 12 hours? Lee did it in only 6. But that was just the beginning of it. By 5 a.m. the next morning, Lee had already transformed into a terrifying Category 5 hurricane, hitting its peak sustained wind speed of 165 miles per hour, an 85 mile per hour wind speed increase in 24 hours, which makes Lee the strongest rapidly intensifying hurricane in the Atlantic Basin on record. The previous record holder was Hurricane Humberto in 2007, which strengthened by 65 miles per hour in 24 hours. Lee would go on to impact coastal regions of Canada as a post-tropical cyclone, albeit much weaker than when it was at its peak. But not even Hurricane Lee can seem to match the power of what the Pacific Ocean has been able to produce. We talked about Hurricane Otis earlier, which was yet another rapidly intensifying hurricane in 2023. If you recall, Otis strengthened 115 miles per hour in one day. Now, that has to be the record holder for the strongest rapid intensification in a hurricane, right? Wrong. For that, we have to take a trip back to 2015. And on the morning of October 20th, 2015, an area of thunderstorms would be designated Tropical Depression 20E. This developing tropical cyclone was located a few hundred miles to the west of Guatemala in Central America. After obtaining tropical storm status, the now named Patricia began to drift westward across the Pacific Ocean, slowly moving towards Mexico. By 10 p.m. on the 21st of October, Patricia was forecast to make landfall in southwestern Mexico as a major hurricane on the evening of October 23rd, 2015. Sitting at 65 miles per hour sustained, the storm had a lot of room to grow still. So grow it did. 24 hours later, Patricia had completely defied all expectations, reaching 160 miles per hour sustained winds. This was already impressive enough, but once you see the peak of its strength, it gets even scarier. The chart you're seeing now on screen is from the National Hurricane Center, and it indicates its peak wind speed reached 200 miles per hour. However, multiple sources from Wikipedia to the Weather Channel claim it reached 215 miles per hour. This report from the National Hurricane Center states a flight level reading had a wind reading of 192 knots, or around 220 miles per hour. So it seems like there's some disagreement on the true peak wind speed of Hurricane Patricia. But regardless, what we do know for a fact is that Hurricane Patricia holds the record for strongest rapid intensification. In one 24-hour period, Patricia went from a 85 mile per hour Category 1 hurricane to a 205 mile per hour Category 5 hurricane, a 120 mile per hour wind increase, which is just absolutely incredible. Patricia would weaken slightly before landfall to 190 miles per hour sustained winds, but that really does not make that much of a difference in a storm this powerful. Patricia would go down as the most intense landfalling hurricane in the eastern Pacific Basin by central pressure, which sat at 932 millibars on landfall. This title was, however, taken in 2023 by Hurricane Otis. Patricia's central pressure peaked at a minimum of 872 millibars, making it the second most intense tropical cyclone ever, only behind Typhoon Tip. So there you have it. Rapid intensification, what causes it, and examples we have seen in recent years to back up the theory that we can expect to see more of these storms in the future as the planet continues to warm. I hope you enjoyed this video. If you found it at all entertaining or informative, please leave a like and subscribe. It really helps us out. Thank you for watching, and we hope to see you again soon.